Tia iwa mauri ora ki te whai au ki te o marama. Hea te hau e wāra mai, tiu he rā ki nāna ia mai te pū putariki i ki uta. Tiki nā tu au te kōtu, ko ia te pau whakairo ka tū ki Waitemata, i oku wairangi e, a tihei wā mauri ora ki a tātou katoa, e hui mai nei i raro i te tuinu o tēnei whare kei te mihi. Kei te mihi atu ki a koutou katoa, nei mai haere mai i roto i tēnei wāranga me ki o Gibbons. I kōko te ngāka ki te kiti a koutou i tēnei wā, mō tēnei wānanga whakahira, mō tēnei wānanga harikoa, he kōko te ngāka ki te kiti a koutou i tēnei wā, nei mai haere mai ki te whakarongo, ki tēnei ahorangi nui, a rā ko Paul i konei. Nā reira he mihi kawana ki a koe, he mihi kawana hoki ki te rangatira o tēnei wānanga hoki, a Giovanni, nā mihi kawana ki a koe. O tira ki a koutou katoa, nā whānui e tai mai nei i roto i tēnei ruma, i roto i tēnei wāhi, mō tēnei kaupapa o te whare pūtaiao. As the faculty Kaiarihi of Science, Te Riki Tuiono's my name. This is actually going to be my last time doing this as well, in this beautiful faculty. I'll warmly welcome you here for this Gibbons lecture, and it's been an absolute privilege to be able to open in our traditional and warm way, particularly here in Ngāti Whātua Ōrākei lands and waters, and just to showcase the brilliance of our speakers that we've had during past and also present, with Paul going to be speaking here today in front of you all. Nā reira ki a koutou katoa, otira ki a koe hoki Giovanni, the HOD for Computer Science, but also a friend as well, who'll be sharing some words of wisdom, but also introducing Paul here as well. Words of wisdom for sure for this kaupapa. Nā reira ki a koutou katoa, he mihi mahana, he mihi hariko ki a koutou, tēnā koutou, kia ora mai tātou katoa, kei a koe te wā, Giovanni.
Apparently, we are not able to disable the microphone, so we had to unplug it physically. Anyway, it's not like there are many computer scientists around. Okay, good evening, everyone. So my name is Giovanni Rossello. I'm the head of the School of Computer Science here at the University of Auckland, and I will be your host for tonight. So this is the last lecture for this 2025 Gibbons series on how artificial intelligence is reshaping education, or read between the lines, we are all out of job. So this series, for those that don't know, is in honor of Peter Gibbons. He was one of the first computer scientists in the country and helped basically creating, the departments and schools around the country in computer science that are now thriving. I would like to also thank the sponsor for tonight that allow us to run this series. So first of all, thank you to the Gibbons family for supporting through the Gibbons Fund. So also support for coming from the School of Computer Science and the Faculty of Science here at the University of Auckland, and then also the sponsorship coming from the Royal Society in New Zealand and ICT Grad School. Now, for running this series, every year there is a lot of work that happens behind the scene, and I would like to thank Professor Jill Dobby for organizing all of that, but also we have Diana, Carmen, Robin, and also our excellent AV team for streaming the series online. Now, it's with enormous and great pleasure, actually, to introduce you Paul, the star of tonight's talk. So I'm making a mess. Apologies for that. I was not expecting to have this kind of mic. Usually I'm not that messy. So Paul is one of the newest professor at the university. So this lecture also will serve as his inaugural. Normally the dean will be running these, or introducing the speakers, the new professors at the university, but she's in Wellington lobbying the government. Go for it. So, Paul. I don't have much to say, so maybe I would try to kind of read some of the many lines that he sent around. So, Paul's main research focus on computing education and educational technology. So he has led multiple international initiatives around generative AI in computing education, and many of his papers have received best paper awards in conferences, actually 16. Most recently, he also received the ACM SIGSAC Test of Time Award, I believe together with Andrew. Yeah. And some says, allegedly, that for each of those awards, basically Paul treated himself to a new pair of Nike sneakers, making Paul the only non-Italian male that I know that has as many shoes as myself. I don't have as many awards as Paul, sadly. Among other awards, Paul has been also recognized as a leader in teaching, both nationally and internationally. He has received the New Zealand National Tertiary Teaching Excellent Awards, then the Computing Research and Education Association of Australia Awards for Outstanding Contribution to Teaching, that's a mouthful, and the QS Reimagine Education Overall Awards. And that was a big deal because he went after big at the School of Computer Science, or teams that were in Ivy League's schools, and basically Paul took that award home. So tonight, the title of the talk is I prompt, therefore I code. Cogito ergo sum, nice. Adapting computing education in the age of AI. So please put your hands together for Paul.
It's all right. It's back. Well, thank you very much, everybody, for coming along this evening. I know that you've given up your Tuesday evening to be here. I'm incredibly grateful to be able to give an inaugural lecture. And as Giovanni mentioned, this is a tradition for new professors at the university to talk a little bit about their research interests, but also to talk about their academic journey. And so one thing I want to do tonight is share with you kind of how I got to this position that I'm in today. For me, the most important part of that aspect of the talk is actually recognizing and thanking the very many people that have helped me along the way and helped me to reach this milestone. As Giovanni also mentioned, this is a lecture in the Gibbons Memorial Series, and some of my recent research has been aligned with the theme of the Gibbons Lecture Series this year, which is AI in education. And so I'm looking forward to sharing with you some of the work we've been doing in that space. But also Peter Gibbons, who the Memorial Series is named after, played an incredibly important role in my own journey to becoming a professor. And so I'm really excited to acknowledge the role that he played tonight. I'm going to start at the very beginning. There are two people without whom I certainly would not be celebrating this milestone tonight. My parents. Both of my parents came to New Zealand at a very young age from overseas. My dad, William, or Bill, came here from Melbourne, England. And my mum, Maria-Lisa, came here from Jyväskylä in Finland. And my parents met in Gisborne, New Zealand, when they were on holiday from their studies, where they were both graduate students at the University of Auckland. So this institution plays a very important role in my origin story. My parents also made some really great decisions in their life, like these. Now, I'm not quite sure what I'm looking at in the picture in the middle. I might be wondering what's happened with my hair, but my mum assures me that this was the fashionable haircut of the time. And then on the far right, there's my brother and I wearing life jackets and wetsuits. And I'm not sure why we're doing that, but my brother Mark has been a really important person in my life, my best friend growing up, and has been a huge supporter of mine. So I'm very pleased that I can talk a bit about Mark tonight towards the end of the talk. What I'd like to do in the very early part of this talk, though, is briefly mention some of the reasons why I became interested in science generally, and computer science in particular. First of all, in terms of role models, my father was a huge role model in my life. My very earliest memories are from the time that my family spent 2 years in La Jolla, California. This is actually the passport photo that I took when we traveled across to the United States. And my dad was an organic chemist, and here he is working as a visiting professor at UCSD. So this is a very early memory, and I don't remember all of the details, but I was always aware from a very young age that my dad was a scientist working at a university. I also thought I would dig into some of my early report cards from primary school and intermediate school to see if there were any clues in there that might speak to why I developed an interest in science. One thing I can say is my teachers were very generous. And I'm not sure why they didn't give me a satisfactory for some of the outfits that I was wearing, but they were always very kind in their assessments of my appearance. I had no idea that they were judging me on my appearance at the time. I did enjoy dressing up as a scientist, so here I am wearing a lab coat that no doubt was brought home from my dad in his lab. It had all kinds of stickers over it. My parents were very interested in me developing an interest in science, and they provided lots of opportunities to learn about science. We had science kits at home. We had a microscope like this one, and I remember looking at all of the prepared slides that came with the microscope, just fascinated that there was this world beyond what we could see with our own eyes. Some of the comments from my primary school teachers were also quite revealing. So one teacher said, "He has an inquiring approach. He needs opportunities to develop and test his own theories." It's perhaps a very polite way of saying Paul is asking way too many questions in class. I don't know what theories I was developing as a primary school student. But I was also clearly interested in performing science experiments for my peers. And I distinctly remember on some occasions going to school with chemicals that my dad had provided to me to run experiments for the other students in my class. And my dad assures me that none of those chemicals were actually too dangerous. And so things seemed to be going pretty well through primary school, and then I hit a bump in the road. I had a bit of a distraction. So my teacher said, "I do not believe that Paul is really realizing his true potential." Wow, what a statement to read as a primary school student. But actually this was pretty serious. My parents were brought into primary school to talk to the teacher because she thought that it would be best for me to spend one more year in my final year of primary school. And this was, of course, terrifying for me as a student at that time. But the reason that I hadn't really been applying myself to my primary school studies was that I'd fallen in love. And this happens. It turns out that I'd fallen in love with the computer that my parents brought home. This was a Spectra Video SV328, 64 kilobytes of RAM. And it came with a manual, and I remember reading that manual from cover to cover, typing in all of the programs that appeared in the manual, and it was just so fascinating to me that you could create whatever you wanted by writing these programs. Sometimes it was frustrating because you would type in a program and you'd run it and it wouldn't work, and that was either because you didn't type it in correctly or because there was a mistake in the manual, which sometimes happened. I did also spend some time playing games, and I managed to find a short clip of one of my favourite games of that era. Fortunately, things seemed to progress a bit more smoothly as I went through high school and then on to university here at the University of Auckland. In high school, I seemed to enjoy science subjects. I studied maths and physics and chemistry, and actually took part in a number of extracurricular exams in those subjects. The photo here is from the school magazine, where I was one of a small group of students that competed in the Australian Science Examination. I only got a merit and not a distinction for that exam. But clearly, computer studies was something that was really of great interest to me. I think very much inspired by a lot of these experiences I had playing with that Spectra Video computer. And then I went on to the University of Auckland and I chose a computer science major. That was clearly where my interest was. And that seemed to go pretty well as well. The picture on the top right there is my brother and I at my graduation for the BSc Honours. My mum collects everything, and at the very top there you see the name badge that she has still kept to this day from when I received the annual prize in computer science. So it's probably fair to say that I was a conscientious student during this period of my life, and I did work pretty hard. I was the runner-up to Ducks at Edgewater College, and then, as I said, I got the annual prize in computer science. And so there is a shield somewhere in the school, and if you look carefully, you can probably see what year I won that. It was a long time ago. But now I had a really big decision on my hands. I'd finished my undergraduate study, and the decision was, should I get a job, or should I continue and do some research? And I'd had various experiences working all kinds of jobs while I was studying. One in particular I remember was working at a soap factory. And there was the cool part of the factory where they actually made the soap. And then there was the part of the factory that I worked in, which entailed standing by a conveyor belt, watching the soap go by, and putting it into cardboard boxes from 3 p.m. to midnight a couple of times a week during my studies. I had great respect for the people that worked there full time. It was a very, very demanding job. But it also helped me realize some of the things I did not want to do for the rest of my life. And I was also working at some other places, like, for example, the Auckland City Council. I was helping them with their website, which was relatively new at that time. And I could see that was an area in which I would potentially be interested in continuing. I also had some offers for working in various software companies at that time. But there was this one experience I had in my final semester as an honours student, which was taking this course taught by Associate Professor Peter Gibbons, Advanced Design and Analysis of Algorithms. And I really fell in love with the subject. Peter was an incredibly inspiring teacher, but also very warm and very compassionate and very kind. And he was a wonderful person to work with. And his research area was combinatorial designs. You may have read a bit about that in the pamphlet for the Gibbons series. Very, very basically, this means trying to arrange numbers so that they satisfy some constraints, very, very basically. An example of the kinds of designs that Peter was interested in were block designs. So this is an example of a balanced incomplete block design where every pair of numbers, like 0, 1, appears the same number of times. It appears twice. And so Peter really brought the subject to life, and I thought, wow, wouldn't it be great to spend a year working on this problem? In particular, trying to construct designs that are very difficult. One of the challenges in this area was that you have this combinatorial explosion where there's just an enormous search space, and you have to come up with a lot of clever algorithms for narrowing down that search space to make it more manageable. So I wrote to my friends at the time. This is actually an email that I managed to find in my inbox, where I wrote and said, a topic with Peter is my only real option. Like, Peter was literally my last hope. And I said, I will definitely try to get him to supervise me. If not, I guess it's the workforce for me, ARG. I think this sort of captures how I was feeling at the time about going into the workforce. And so I said, I'll talk to Peter as soon as possible. And then I wrote to Peter, and I wrote this waffly email saying, I'm not too sure of what I'm going to do. I'm not sure about this. I'm not sure if there's any particular time. And Peter, in his very kind and compassionate manner, wrote back this wonderful email to me, basically saying, it's great you're thinking about coming back, but then I don't want to presume anything, but if you would like to work with me, I'd be very happy to supervise you. And this, probably to this day, is the most important sentence I've ever received in an email, because that was the reason that I chose to do this master's with Peter. We had a great year. I could talk for an hour about the work we did together, but we did end up with something like a dozen new results from this master's, and it was a really fantastic year working with Peter. Peter also opened doors for me, so at the end of this year, he had helped me organise a scholarship to do a PhD at the University of Toronto. This, in fact, was the same university where Peter had got his PhD. And so I was initially very excited about going to Toronto and continuing studying and doing research in this area of combinatorics. But I had 6 months before I had to be in Toronto. And so Peter said to me, why don't you spend a little bit of time here teaching, just for a semester, and then once you've done that, you can go and start your PhD in Toronto. And so now we kind of move into the academic journey part of the talk. And I thought this was great. And I was going to spend 6 months teaching. And what happened was I got into the classroom and I just loved it. It was the greatest thing. And as that semester progressed and I was enjoying more and more teaching computer science, I thought, well, going to Toronto to do a PhD is sort of a means to an end. You know, eventually I'll get the PhD and then I'll be able to teach. But actually I'm teaching now and I'm really loving it. And so my career started as a teacher in a teaching role. I began as a tutor, and I actually spent the first 12 or 13 years of my career before I enrolled in a PhD eventually in a teaching role. This was a wonderful, wonderful time in my life. I had lots of wonderful memories from this time. The pictures that you see there on the far left, they were, well, the one on the top was a staged photograph, came from one of my teaching portfolios, but those two pictures kind of show the extent of the different kinds of classrooms I was teaching in. Very small one-on-one lab settings and also very large lectures. There are a few people I just want to briefly acknowledge who were very influential to me in developing as a teacher. The first person you see there is Peter Beer. Now, I know Peter's around here somewhere. There's Peter. So Peter Beer is, first of all, an absolutely fantastic teacher. He's a National Tertiary Teaching Excellence Award winner. But he's also an incredible performer. And so he would arrive to class on his unicycle, you know, juggling clubs, and then he would take breaks during the middle of the lecture and do all of these tricks. And I know then when I would come along in the second half of the semester and I'd see all the students looking at me, judging me, thinking, what are you going to do for us when you take a break? And I would say, let's do some practice problems. And Peter is also the reason why, to this day, every time I get a end of semester teaching evaluation, I get comments saying, Paul's a good teacher, but it'd be great if he could ride the unicycle. So thank you, Peter. I'd also like to briefly just mention the A team, Andrew, Angela, Anne and Adriana, who I did a lot of teaching with, particularly in that early part of my career. These are, again, fantastic teachers who show an incredible dedication to outcomes for their students. And it really was a pleasure working with them during that period. And also I'd like to just acknowledge the support I received from colleagues and heads of school. I was very fortunate to receive some accolades for my teaching. These were always prompted by someone coming to me and saying, hey, I think you should give this a shot. And so I'm very grateful to all of the support that I received during that period. There was another really, really big part of my life during this time, and that was being a basketball player. I was in fact reminiscing with my friend Alan Ovens here because he and I used to play a lot of basketball together. In fact, I wasn't sure whether I was a teacher who played basketball or whether I was a basketball player who taught some computer science. And some of the memories I have of this period were playing in the National Basketball League. I played for the Harbour Heat. This picture is actually taken from the one on the far right there is taken from a slam dunk competition that was run at the old recreation centre. So this was a really great time, and you'll be pleased to know that I also organised the annual computer science staff versus student basketball games. And during this period, the staff team were unbeaten. Partly because we had Patrice the Enforcer Delmar elbowing students at one end of the court, and then I was scoring all of the points at the other end of the court. It was a beautiful time. By the way, I should point out that I don't play basketball anymore. As I got older, there were many signs that I should probably not lace up my boots anymore. Injuries take much longer to heal. I managed to ignore a ruptured Achilles tendon. I managed to ignore knee surgery to fix cartilage damage in one knee. I managed to ignore broken ribs and broken fingers. And I kept playing, and eventually I did get another sign. And I was playing in a Tuesday night league at the old recreation centre, and I just finished warming up. And by the way, at that time, warming up took me an hour, so I'd been doing all my warm-ups and my stretching. And I was walking down to the basketball court to start playing the game. And just before I got down to the little tunnel, these two young students came ahead of me, and they were dressed in their basketball gear. And I overheard their conversation, and one of them turned to their friend and said, "Hey, who are we playing tonight?" And the other one turned back and said, "Oh, we're playing that team with the old guy in it." And then as I was walking behind them, I thought, well, that's so weird because there are no teams here that have old people in them. And then it was a bit like a cartoon. The light bulb, ding, just went on. And then I thought, yeah, maybe it's time for me to start thinking about other things. I do want to mention one really influential experience I had during this time. So I was a senior tutor and I applied for a research and study leave. And this was something that I was eligible for, but I still felt that it would be important to have a really strong application in order to be able to go and spend a semester overseas. And I was very fortunate to get a letter written by distinguished Professor Carl Wyman. Now, he was a Nobel Prize winner. And so the faculty staffing committee seemed to be quite happy that I was going to go and spend some time working with a Nobel laureate. And Carl Wyman had set up this science education initiative at the University of British Columbia. A fantastic initiative where these discipline experts, who were also educational researchers, were embedded into the different departments and schools. And essentially their job was to encourage the professors and the instructors to embed these innovative pedagogical approaches into their teaching, but more importantly to also rigorously analyse whether or not these approaches were actually working. And this had a huge effect on me because I had been exploring all kinds of ideas, but I really loved this idea of being very, very rigorous about the evaluation. And so when I went and spent the semester with Carl's group, I had started some projects. And one in particular I spoke to Carl about, and he was very interested in the idea. And so when I came back to New Zealand after that study leave, I explored this idea in a lot more depth. And really the idea was, does learner-sourcing work? And the original idea for this came from feedback I used to get from my students when they would fill in their teaching evaluations, which used to be done on paper. And they would often at the end of the semester say, we really want more practice exercises. We really want more opportunities to practice. And there was only one of me, and I couldn't write hundreds and hundreds of practice exercises every semester. But this was around about the same time that user-generated content was all of the buzz. And so I thought, well, wouldn't it be great if we could actually get students to create these practice questions for each other to use for practice? This was the basic idea. This turned into the Peerwise project, which over many years has collected a very large quantity of learner-sourced content. Multiple choice questions in all kinds of subjects that you can imagine. If I think about this project, the one thing that to me really has been the most rewarding has been fostering this community of educational researchers who were also doing their own research using the data that was collected by the platform. So several hundred people in this community who've published their work as a result. And actually, I know recently we've had a lot of people doing some really cool work. In particular, Chiming Bao over here, Lin Ni, they've been doing really great work using this very large data set, developing machine learning algorithms to do things such as automatically producing high quality explanations for some of this learning content. So it's really great to see that. Not to mention having this body of literature was also very useful when it came time to apply for various awards. And Giovanni did briefly mention this QS Reimagine Education Award. There were 1,200 projects from 40 countries submitted this year. And I remember I received an email a few days before I was about to fly to San Francisco for this event saying that the Peerwise project was in the top 10, and I couldn't believe it. I was so excited. I even went out and bought a tie, and then I went to this event, and it was a really a surprise that it won the award that year. I had a look at the logs because it's been many years since I've spent any time doing any kind of meaningful development of this tool. I used to spend a lot of time writing the software and maintaining the tool, but I haven't really touched it for about a decade. And yet still, when I looked at it most recently, there are about 250,000 page requests every day. And I do want to acknowledge the people at Connect, people like Reed Watson and Jamie Walker and Tucker Chafe, who've been maintaining these servers and are still, working and working well. So then, this Peerwise project also helped kickstart some ideas for a PhD. In particular, we had a lot of evidence that there were certain actions within these platforms, these learner sourcing platforms, that were very beneficial for student learning. And so to me, it was really interesting if we could influence students to engage more in those activities that we knew were beneficial for them, leveraging some of the mechanics that are popular within, for example, digital games. And so Peerwise became one case study in a broader PhD that looked at this work. My supervisors, Ewan, I saw Ewan before. Ewan and Dawn, thank you so much. It was a fantastic 6 years because it was done part-time, maybe 7 years. It says there, 6 years, 7 years, okay. Now, in the same way that Peter Gibbons was kind and compassionate and gave me a nudge just at the right time, Dawn also was willing to give me a nudge, but threatened violence to do so. And so she said, look, if you don't get started on your proposal, I'm going to nail your feet to the floor. So I needed that. So thank you. Anyway, this did open doors to me. Having completed the PhD, I then went and was able to broaden my research work and supervise students and so on. And I was very fortunate to be able to move into a senior lecturer role after I'd completed that PhD. In the interest of time, I'm not going to talk about the research broadly, but just want to summarize 2 things here. So I took all of my papers and I gave them to ChatGPT and I said, produce a summary, and it's done a reasonable job. A lot of the work that I've done falls into the broad category of novice programming. So how can we help people who are learning programming to succeed? And if you look at the literature, this is actually a pretty difficult task for many learners. One of the barriers to learning programming that has traditionally been very challenging has been learning the syntax of a language. I remember it was very eye-opening for us when we first launched our web-based programming platforms and we could suddenly log all of the actions that students did within those environments. And we would see some students spending literally hours trying to put semicolons in the right place and curly braces in the right place, and incredibly frustrating experience for them. Not to mention, if they make one of these mistakes, they typically get some very horrible cryptic feedback from their compiler or interpreter, which doesn't help them at all. So this syntax barrier was a huge barrier for many, many years. Very recently, with the rise of AI, I've also been interested in how we can utilize AI for adapting the way that we teach, particularly programming education. And so this kind of moves us into the Gibbons part of the lecture, where I want to focus on the use of generative AI in computing education specifically. Now, AI is a huge topic. It's not just having an impact in education, it's of course having an impact that's much broader than that. Even within education, there are lots of risks and lots of opportunities, and the kind of headlines that I've listed up here broadly categorized into all of the great things that AI can do for us, right? We can use AI to create these personalized learning environments. On the other hand, you see these concerns that everyone's cheating using AI. The answer might actually be in the middle there. I did find this headline saying, teachers worry about students using AI, but they love it for themselves. If only we could have AI for ourselves, but the students couldn't have it, the problem would be solved. Unfortunately, that is not possible. So why I think computer science is a particularly interesting subject area in which to study this is that AI is really having, I think, an outsized impact in this subject area. So the data that you see on this chart comes from an education report published by Anthropic, which is the company behind the Claude model, which is one of the leading large language models. And they took 1 million anonymized conversations between students, tertiary students in the United States, and the Claude model. And for each row on this chart, where you see a subject area, the blue dot represents the proportion of students who have that subject as their major. So it's basically how popular that subject is. The orange dot represents the proportion of those anonymized conversations that were in that subject area. And you can see that computer science is a massive outlier here. One of the reasons for this is that these models have become extremely good at generating code. And learning programming has traditionally been the sort of the gateway skill to computer science. In order to excel and understand more advanced topics like data structures and algorithms and computational efficiency and artificial intelligence and cybersecurity, you need to have a solid understanding of the computational principles that you learn from programming. So these models are having a real outsized effect in subjects like computer science because of their ability to break down those barriers to producing code. Here is an example of generating a very basic Space Invaders game purely through natural language prompting. Now, we're kind of used to this now. We see these models spit out code. But this is mind-blowing to people when they first saw it back in sort of 2021. The fact that these models can just magically produce code is really quite incredible. And this has led to all kinds of headlines and statements like the one that you see here from Jensen Huang, who's the CEO of NVIDIA, who provide a lot of the hardware that powers these models, saying things like, "We have closed the digital divide. Everyone is a programmer now. You just have to say something to the computer." And I don't think that's true. I don't think everyone's a programmer, but certainly everyone can produce code now. Right? You can produce code just through these natural language statements. This has led also to the rise in something called vibe coding, which I was talking to a few people before this talk began. So the idea with vibe coding is that you just provide these natural language statements to the model. If there are errors, you just throw them back to the model. You don't pay much attention to the code, and eventually you'll get to a working solution. Now, even the person that coined the term, Andre Karpathy, who is one of the co-founders of OpenAI, he said that vibe coding is great for hobbyists who just want these throwaway projects. It was never intended to be a legitimate way to build good, high-quality software. And what you typically find is if you vibe code on some fairly complex task, you end up with screeds and screeds of unmaintainable code that doesn't work. I want to share with you an example that's much closer to home. So in our computer science school, one of the software tools we use a lot is CodeRunner. And CodeRunner is a web-based programming platform which we've used in our labs. We also now use it in our tests for assessing that students can typically write programs in response to a problem statement like the one that you see here. Now, have a look at how a student can solve one of these problems. They can select the problem statement. They can copy that to an editor like, for example, VS Code. And before they've even had time to type a few characters, boom, out pops a solution. And now they can copy that solution and they can paste it back into CodeRunner, and it will pass all of the tests and they get their marks. So now we're in the situation where the sort of traditional way that we assessed students' abilities to write code is sort of no longer viable when they are able to use these tools. In fact, you can solve all of these programming problems without even reading the problem statement. So what does this mean for the way that we should be thinking about adapting our approaches to education? I should point out that it's not just educators that have concerns about this sort of thing. When we first were exploring this, we actually observed students in the lab using these tools to solve a variety of programming problems. And we then asked them about their experiences. And the quotes that you see here come from those students who had just used this Copilot tool. And they would say things like, "This will make me a worse problem solver because I'm relying on it to help me out. I don't have to know how to code, it would just do it for me." And this is obviously not what we want. What I would like to do is present 3 principles that we can think about for leveraging AI in programming education. And here my focus is mainly again on novice programmers who are learning the fundamentals of computation. The first principle is that we should be thinking about ways to leverage AI to strengthen foundational skills. I think it's tempting to say things like, wow, these models are really good at doing this low-level stuff, so students no longer have to learn that. But actually, we want students to be critically evaluating the outputs of these models, and they can't do that if they haven't built a strong foundation themselves. But maybe we can use these AI models to actually help students learn these skills more effectively or more efficiently. The second principle is around leveraging AI to guide students and not just reveal solutions. If you think about the previous example with Copilot, you type a little bit of, you type a comment and suddenly the solution pops out. Now that's fantastic for professional programmers who want to solve problems efficiently, but these tools were never designed with novices in mind. Maybe just throwing solutions at students isn't the best possible learning experience for them. And so maybe we should think about ways that we can actually scaffold and guide students more and not just reveal these solutions. And the third principle is around the way that we should think about these new and emerging skills. Clearly, we do want students to be able to communicate and work effectively with these AI models. And so we do need to develop skills like the ability to construct prompts that effectively solve computational tasks. And what I'd like to do in the remainder of this section is show 3 examples, one for each of these principles, where we've actually deployed these solutions at scale and we've begun to learn a few things. I'm certainly not arguing that these are the only things that we should be doing. I'm also not arguing that they replace what we've been doing previously, but these are ideas that we can use to augment some of our traditional instructional approaches. So firstly, strengthening foundational skills. How can we use AI models to help strengthen really important critical skills in students learning programming? I want to motivate this by a post that I saw on the SIGC mailing list. So SIGC is ACM's special interest group in computer science education. This was posted a couple of years ago by a concerned instructor who said, I'm shocked to see how good ChatGPT is at writing introductory level code. If it tears the heart out of the learning process in CS1 and CS2, we're going to find in just a few years 4th-year students who basically can't do anything. Now, one fundamental skill that we would want every student at the end of an introductory programming course to have mastered is the ability to read and evaluate code, read and understand what code is doing. These models are now so good at producing code, we clearly want our students to be able to make sense of that code and understand what it's doing so they can choose whether or not it's actually the solution that they want. So going from a fragment of code to a sort of an explanation or an understanding of that code is a critical skill. One of the classic ways that we've both developed and assessed this skill at the introductory level is with these explain in plain English problems. That's the name that they've typically had. So this is where you have a fragment of code and you show it to a student and you ask them to explain it in plain English. Now, I know that we have a lot of computer scientists here who've probably glanced at this and can immediately work out what this code is doing, what the purpose of this code is. So a reasonable solution to this problem might be it finds the position of the rightmost 0 in an array. Now, what do you think happens if we give this problem to 1,000 students? What happens is we get 1,000 very different answers to this problem. And one of the biggest challenges with these explain in plain English questions is it's always been really difficult to grade them at scale. Often it's subjective. You don't really know if the student has understood what they're saying. Maybe they've misused a word. And of course, it's very time consuming. So one of the ways that we can use AI to help with this particular problem of being able to deploy these explain in plain English problems at scale is with an approach called code generation-based grading that we've been exploring. So you can start by showing the student a fragment of code and asking them to explain it. So now the student writes an explanation in their own words for what they think that code is doing. Now we can take that explanation that the student has provided and we can give that to a language model to generate code based on the explanation. And so now we've got code A, the original code fragment. We've got code B, the new code fragment. which is generated from the student's explanation. And what we care about is, are those two fragments of code functionally equivalent? They might look different, but what we care about is, do they behave the same? And we can verify that automatically by executing code B against the test suite. And so now, not only can we deploy these problems at scale and give students immediate feedback about their explanations, but students can do this in an iterative way. If they make a mistake, they can try again, and they can develop this understanding of the relationship between natural language prompts and the code that those prompts generate. So we've been deploying these tasks in the Prairie Learn platform, which is a widely used platform in the US. Here is an example of one of these problems being solved by a student, where they submit the description. In this case, it isn't quite right, so they have to reflect on the feedback they've been given, and they'll go back and eventually tweak that prompt. When we've asked students about this, we've heard students say things like, I enjoy this new outlook on AI as a tool rather than a problem in the learning space. Because often students hear things like, don't use AI, be cautious about using AI too much. But here they can see the value of using AI to provide them feedback on their understanding of these code fragments. I want to acknowledge David Smith, who was a PhD student at the University of Illinois Urbana-Champaign. He's now an assistant professor at Virginia Tech, and he's been leading a lot of this work. There are lots of cool things that we're also working on here. So one of those is providing fine-grained feedback about the prompts that students write, segmenting those prompts so that we can highlight which part of the prompt generates particular output in that code. This is useful, for example, if we want to guide students towards providing higher level, more abstract prompts, which is typically the goal of these explain in plain English problems, because those typically have fewer segments. The other thing is that you'll notice these problems are called explain in plain English problems. And English has often been a barrier for students learning programming. Keywords, for example, in a language are in English. Error messages are in English. And we often have students who might know exactly what the code does, but they aren't able to express the purpose of that code very well in English. And one of the advantages of using these large language models is that they're already good natural language translators. And so we've also been exploring using these problems at scale in other countries. India, for example, is very interesting because there are many, many languages spoken across India. Okay, so the second example is around using AI models to provide guidance to students and not just solutions. Now, I do miss something. I miss when we had an assignment due and we'd have a line of students outside our door holding USB sticks saying, my code doesn't work. And we no longer get this. We don't see students doing that anymore, which is kind of sad on the one hand. But when we used to see these students, with their code and they were stuck, one thing that we wouldn't do is, take their code or their laptop and just say, oh, yep, there's your problem, solve it for them and send them on their way, right? Instead, we would guide them. We would ideally use our expertise as educators to help get the student unstuck. One of the reasons we're no longer seeing as many students come to our office hours or to our doors, or perhaps to our lectures, is that Gen AI tools are now being used as the first port of call when students are stuck. And that's understandable, they're very good. So this data actually comes from a survey that we ran, this is a couple of years ago, so it's fairly old data now. But even back then, when we asked students, what is your first port of call when you want to seek help for some problem, we saw that more students were saying using Gen AI tools than actually saying talking to the course instructor or the TA. Now, there are lots of good reasons why this might be. I mean, availability is an obvious one. Gen AI tools are available all the time. There's also the benefit that Gen AI tools aren't going to judge you, right? And you maybe believe that you have a question that might be perceived as silly by your instructor and you don't want to talk to them about it. One thing I do want to acknowledge is that Gen AI tools are not only available, but actually have great potential as digital teaching assistants. And I know we've already talked about this earlier in the Gibbons series, but I want to show you an example. This example involves me holding my phone and pointing the camera at a piece of paper. And for those computer scientists in the room, you will recognize this data structure as a very important one, a binary search tree, but it's not quite a binary search tree because one of the nodes is out of position. But I want you to just pay attention to how natural the interaction is between the student, me in this case, and the model which is giving me feedback just based on the signal coming into the camera.
Well, see this structure here? Is this a valid binary search tree?
Yes, that looks like a valid binary search tree. The root node is 100, with 50 as the left child, and 7 as the left child of 50. Each node follows the rule. Left child is smaller than the parent node. Good job.
So see this node here?
Yes, I see the node you're pointing to. What's your question about it?
Well, can you give me an example of a value that if I inserted it into this binary search tree, it would be added to the right child of this node?
Sure. For the node with value 50, a value greater than 50 but less than 100 would be added as its right child. For example, inserting 75 would place it there.
So kind of like that?
Exactly. That's perfect. Now 75 is correctly placed as the right child of 50. Great job. So the in-order traversal would be 7, 50, 75, 100, 120, 130.
What about this node here?
That's the node with value 90. It looks like it's placed as the right child of 75. If you have a specific question about it, feel free to ask.
Does it look like it's the right child of 75? It looks to me like there's an edge here.
Ah, I see what you mean. Yes, 90 is correctly positioned as the right child of 75. The structure looks accurate. Is there anything else you'd like to check?
So clearly great potential, right? That's a very natural interaction. But when the model makes mistakes, it's also potentially really problematic. There are, however, some kinds of questions where these models are very, very good. So they may still struggle with some of these visual-based problems. But if you have a piece of code and you want to ask questions about the code, these models are exceptionally good. So imagine a student who's stuck on a piece of code, they don't know what to do next. As I mentioned at the very start of this example, as educators, we would think about leveraging our many, many years of expertise to get that student unstuck, to just nudge them in the right direction. We were curious about who would write better next step hints. So if we have a piece of code where a student is stuck, and then we want to generate a hint that would be a really good hint to just get that student unstuck, would a set of experienced educators produce better next step hints than AI models? And so we looked at exactly this, and we had a collection of code where students had legitimately become stuck. We then had 5 experienced educators write what they felt were the absolute best next step hints. We had the models do the same thing, and we put all of those hints into a pool, and then we had another set of independent educators judge the quality of those hints. And what we found is that the AI models were not just indistinguishable from experienced human educators, but actually the best model using the best prompt was significantly better than human educators. And I was one of the human educators, so I felt really bad about this. But it also means that in some situations, these models can provide really excellent high-quality hints. So we used this idea to deploy a project called Code Help, which would never reveal solutions to students, but would only guide them towards a solution that they could achieve on their own. Here is an example of a question and the response from the model. I particularly like that the model's very encouraging. Again, this was part of the prompting, so it says, keep going, you're doing great. One thing we observed with this project is that students would use the AI model to seek help at all hours of the day and night, right? So even from the very early hours of the morning right through to the late hours in the evening, clearly valuing the availability of the model. And that's something they told us when we asked them what they felt was the most desirable characteristics of these AI teaching assistants. The other thing they said, scaffolding. They really appreciated these models were not just revealing solutions to them, but actually guiding them towards a solution. Now, this Code Help project is actually a couple of years old now, but Tony is a PhD student who's doing some really fantastic work looking at embedding these kinds of AI systems into for example, discussion forums. In fact, Anna as well is doing this work. And so I think, and also we've got a Cogniti trial happening at university. So I think there's lots of potential for this type of thing if it's done well and thoughtfully. Okay, and the third example is developing new and emerging skills. Believe it or not, if you ask the model, don't make up answers, my career depends on it, bro, it does actually work better. That's not true. The term prompt engineering has sort of become a little bit pejorative in some ways. You know, there were all of this hype about people becoming prompt engineers and earning lots of money. But the reality is that we do need to think about how do we train students to write high quality prompts for solving computational tasks, because this is now an authentic skill. There was a really fantastic working group report by Claire and colleagues. Tony, Claire is sitting there. Alison, you're also on that group. One of the quotes which came from a professional developer was, many IT professionals, the quote from the report said, many IT professionals identified prompt engineering as a critical competency due to the rise of AI. One participant stated that the number one skill everyone should learn is prompt engineering. So how can we develop this skill? What's a sort of safe, effective learning environment for helping students develop these prompting skills? So remember previously we talked about code reading. You'd show students a fragment of code, they'd have to explain its purpose. We also want students to develop the skill of code writing. This has traditionally been an outcome of an introductory programming course. That is, starting with a specification of a problem and the student then generates code. This pipeline shows the standard way that we would construct these code writing problems. The instructor would first of all think of a problem. So maybe, the instructor might realize that the students need to learn about, for example, arrays. And so in their head, the instructor would construct, some problem related to arrays. Maybe I want to search for the rightmost zero in the array. But then what the instructor would do is spend all of their time creating this high quality specification. And of course, I've written many, many programming problems over the years by doing exactly this. And then we would give that specification to the student who would turn it into code. And then that code would invariably be evaluated by an auto grader. But now that step going from specification to implementation can be solved so effectively by large language models, as long as the specification is clear and unambiguous, we can actually move students up this hierarchy. We can now have students construct those specifications for the model to generate code from. Now you might think, but surely this is obvious. Surely it's easy to write these natural language prompts for solving computational tasks. Well, that's not in fact the case. So we observed students solving problems like the one that you see here. So the picture on the left kind of illustrates a problem where you are swapping the upper left and lower right quadrants of a matrix or a two-dimensional array. And so we asked students to prompt ChatGPT to write a program to solve this, and here is how one of these sessions went. I want you to write a Python program. Sure, what would you like the program to do? I have a square matrix and I want to swap the first half of the rows with the second half of the rows. Now that's not quite right. I want to swap the first half of the rows with the second half of the rows, but ChatGPT will produce output code for you. So then the student says, well, that's not exactly what I meant. I actually want to swap the first half of the elements in each row with the corresponding elements in the second half of the rows. Again, that's not quite right. And so one of the ideas that we've been looking at is this idea of prompt problems, where we can provide students with these graphical representations of problems, like the one that you see here, where the goal is to swap or sort the values between two index positions, start and end, and then provide an environment where students can practice writing prompts to solve that task and get feedback on their attempts, and they can iterate on these attempts. So here is an example of this in action, where the student is, first of all, typing a prompt saying they want to try and sort all the values between the start and end index. Now, in this case, they realize that the name of the function is wrong, but everything else looks pretty good, so they're just going to edit the code directly in this case, because it's quicker to just change the function name by editing rather than issuing a brand new prompt. Now, it doesn't work, and it turns out that there is an error, and they realize that actually the value of start and end can be the same, so they just clarify that. And now there's another output from the model, In this case, it looks pretty good, but it doesn't quite work because there's a boundary condition error in the very first conditional statement. They realize, actually, this should be a greater than instead of a greater than or equal to. So here is an environment where students can practice writing these prompts, but also manually writing code as well. And we've designed all kinds of exercises, including, for example, data science exercises where students are manipulating data in a spreadsheet and so on. We found mixed reactions to this approach. So some students love it. They say, this is a representation of how our generation will program as software engineers working together with AI, right? Really positive. Other students have really been concerned. You've just ruined every piece of self-esteem I had regarding coding. I know full well that it would have taken me around 35 minutes to figure out how to create those functions, and that damn computer did it in seconds. Robots are going to own us within years. So we do need to think about addressing these kinds of concerns and making sure that students realize that they're working productively with the AI models. I do want to recognize Cesare and Victor, who've done a lot of work on this project. And the last piece of data I want to mention here is that one of the concerns with this approach is that students might think that just writing natural language prompts is all they need to do. But actually, when we ask them what combination of natural language prompting and manual code editing do they think is the most effective combination, most students lie right in the middle. They believe that they need to learn both of those skills. And in fact, empirically, we've seen this when students are solving problems. As the problems get more and more complex within that platform, they're more likely to incorporate manual code editing alongside the natural language prompting. And now in the last 2 minutes, I just want to close with some reflection and thanks. First of all, I'm very grateful to have had the opportunity to work with some fantastic students. I've also worked with some fantastic co-supervisors, Danielle and Andrew shown here, along with my first PhD student that graduated, Devi. I also want to acknowledge that some of this work is funded by Meta and OpenAI, and I think it's incredible that these companies, which are literally building the state-of-the-art foundation models, are also interested in supporting and advancing computing education research. I actually flew to Menlo Park for the Meta grant, and I stepped off the plane. I was put straight in front of a camera and asked to explain what it was all about. And it actually solved for me a long-standing mystery around a comment that a student wrote on one of my set evaluations once, saying, less of the annoying, unnecessary hand gestures. And suddenly, it all made sense to me. I really want to thank SIGSE. So SIGSE is the Special Interest Group on Computer Science Education. The opportunities for collaboration that SIGSE provide are second to none. We actually have the chair of SIGSE here in the audience, Alison. I'm very, very grateful to what SIGSE has done for my career. One of the models they run is a working group model where typically for 6 months you can be put in a group with up to a dozen researchers, both junior and senior, working on a problem for an extended period of time. And this has been a really fantastic experience for me, and I think for other people working in those groups. There are just a few people I really want to thank related to this theme of collaboration. Andrew Luxton-Riley, I can see Andrew sitting at the back. Andrew is by far my most frequent collaborator. I haven't counted how many papers we've worked on together, Andrew, but I know it's quite a few. And Andrew is the most fantastic research colleague that anyone could hope to have. I was very fortunate. We'd won a Best Paper Award and we were whipped up on stage, and I was overcome with emotion and put my arm around Andrew, and someone snapped this picture. So Andrew, thank you very much. And also Andrew really paved the way in terms of going from the senior tutor role through to a professor role. And I always think, much easier to follow in someone's footsteps. So thanks very much, Andrew. I've also really benefited from working with James Prather, Brett Becker, Juho Leinonen, and Steve McNeil in particular. These people have not just become fantastic research collaborators, but very, very close friends, and it's an absolute pleasure to work with them. Not to mention Arto, Ewan, Burkhard, Reeves, Jackie, Michelle Saranga, and hundreds more. I do also want to acknowledge some fantastic colleagues and opportunities that I've had while I've been here at the university. The School of Computer Science is a big school, And I just thought I'd thank everybody, so I took a photo of the picture wall. The reality is I have been here for quite some time, and I've got to know the people that have also been here for a while, but also I've had an opportunity to meet a lot of the new staff through, for example, my role recently as Deputy Head of School Academic. I'd like to thank Giovanni for giving me the opportunity to serve in that role for a while. The education team who are sitting in the back row there, Bruno Federici in particular, who said, hey, why don't you try and be Assistant Dean Academic for a while? I've learned a lot from Bruno and from working with the others in that team. Murray Ford as well as pictured there. Ursula, the best program portfolio manager that the university has. Sean Maguire, Erica Kroger, who's now stepped into Sean's position. Just tremendous. I won't say any more about the slide other than to say that it's really been a pleasure. Often you think about service as being kind of a burden, you have to do these things, but the number of opportunities I've had through my service roles have been just fantastic. And I started my talk with family, and I'm going to end with family. I showed a picture of my parents originally. Here are my parents now, Sir and Lady Denny. I'm incredibly proud of the achievements of my father. Not only is he a brilliant scientist, his knighthood was for services to medical research. Not only a brilliant scientist, but also he had a work ethic that truly had to be seen to be believed. And I feel very fortunate to have had my formative years at home observing that work ethic firsthand. And so I'm very grateful to have learned from him. I certainly will not get a knighthood for computer education research, but nevertheless I've learned a lot from my dad, and I'm very proud of his success. My brother Mark, who's been my best friend and who has been my greatest supporter throughout my life, has given me the greatest big brotherly advice that anyone could wish for. I'm very grateful to Mark. And my very last slide is reserved for Kath. I've shared with you this journey of going from a tutor through to a professor, and there has been someone who's been by my side for the last 24 years over that entire journey. And it's been an absolute pleasure and a privilege, and Kath has shared in all of my many failures and helped to commiserate and support me. She's also been there to help celebrate the occasional success along the way. And while I know tonight is a chance to celebrate this particular milestone, I'm incredibly proud of the success that Kath has achieved in her own career. And so I just want to thank you very much for being there. I've been whispering something to Kath for the last 5 years, over and over again. This is the last deadline for a while, and I know I'm going to have lots of free time after this. I am going to stop working so hard now. Thank you very much, everybody. Really appreciate your time.